In this video, I'll talk about 6 tips that I think are very important that everybody should know if you want to use R for data science or programming or just anything in general. Tip number 1, know where to get help. You need to know how that you can get help and to solve the problems that you are facing, where you can find, for example, what functions to use or how to change something or anything like that. Now, the most basic way to get help in R is, of course, to just look at the help files that are in R. Every package in R comes with extensive documentation, and for every function you can just type question mark and then the name of the function. You get extensive help file that explains you all the arguments that you can use in the function. Few things that you should know if you read this. You see, for example, here default equals and then a vector with a lot of options. That doesn't mean that you have to specify all these options. It actually means that you can only specify one, and you can only specify one of these options, and by default it will pick the first one. So this will tell you that you don't actually have to specify it, because by default it will give you value, and these are the options you can choose from. It also tells you, for example, that this verbose argument here is set to true by default. It means you don't have to use it. Normally you only use it if you want to set it to false. Another useful trick in R is that you can actually search in R as well using the double question mark symbol. So if you remember vaguely a function name, but you don't really know exactly what it's called and what package it was in, you can just type question mark, and then something similar to the function name, and then you get an answer here that says what functions belong to that name. Of course, you can also search outside of R. You can just go to Google, how to perform correlation in R. And there has been so many questions about R online that you'll probably get like really good materials, really good explanations, maybe even videos, things like that. Another option is the website stackoverflow.com. It's very good. It has a ton of question and answers on programming questions. You can just search, for example, rotate x-axis label ggplot2, and you get a ton of answers. It also has a really nice tagging system, so you can press this R tag and get all the R questions, which are almost 500,000 of questions already. And there's a very active community as well, so if you have any questions that are not answered yet, you will get an answer pretty fast. A newer option for this is, of course, AI tools like ChatGPT, GPT-4, and maybe there's even a newer tool out there when you're watching this. They work really well. You can just type something, how to rotate x-axis labels in ggplot2, and it will give you an answer, and usually these answers are very correct, they're very good, and they also you also get some code examples as well. One thing to keep in mind here, of course, is that AI tools are still just only generating predictive tests. It doesn't actually evaluate it to see if it works or not. Sometimes you get code that doesn't work, but it actually works pretty well now already to help you write your R code. There's actually a add-in already for RStudio that allows to use ChatGPT directly in RStudio. It's made by Michel Nivard, and you can install it directly from Cran or from the GitHub if you want the developmental version. And it has a lot of really nice tools that you can use. For example, I can go here, select this text, I go to add-ins, and I can say ChatGPT in source, and then it's just sending this question with the R code to ChatGPT. So now we got a new code here that actually fixed the mistake that was there, which is that this 3 here is a character, not a number. It puts it in our markdown format, which is not my favorite, but you can use it, of course. And it gives you a code that actually works. Right? It can also be used to fix the error or to add things. So for example, here say simulate the data that works with this code, rotate the x-axis label, and then add a futuristic neon themed color. Let's see what ChatGPT comes up with. And there we have the response from ChatGPT. It actually gives you some code to simulate. And then it gives you an example with rotated x-axis labels. But one thing to note here is that it actually suggests a package that doesn't exist. So yeah, it's still, of course, early development with data. Okay, tip number 2 is a very easy tip, but I still see that many people do this wrong. And that's simply, if you're analyzing data and you want to load it into R, put the data in the same folder as your R script. So for example here, I tried to load the dataset, but it doesn't work, because it did not set the working directory correctly. I could do like set WD and then type the working directory, things like that. But that's not very nice, because then if you share your script to someone else, they have a different directory, so your script is not reproducible, and it will give errors for them that they need to solve themselves. Now, What I always do is I put the data in the same folder as the script. And then in RStudio, what you can do is very simple. You go to session, set working directory to source file location. Then it will automatically set your working directory correctly, and then you can read the data. I always write any code I do, assuming that this has been set, so that I always write, okay, read.csv data.csv, and then it's up to the people that use my code to put it in the same folder, which you should do anyway. Tip number 3 is something that I will always point out to anyone that shows me their R code and where they're doing this, and that is to write true or false fully rather than the shortcuts T and F in R. So in R you can write capital T instead of capital letters true to indicate that something is true, and that saves you typing 3 characters, so people like to do that, but it can lead to very, very big problems. The problem with the shortcuts of T and F is that they can be overwritten in R. So for example, here I try to get the normal distribution under the z-score 1.96. Well, that should be about 97.5. And I say lower tail equals true to get the lower tail, so the lower bound, so that goes correctly. But I could actually overwrite T for example, as a set of numbers. So for example, I can do a psychometric simulation study where I am simulating true scores or TDAs, and I use the letter T. It can happen by accident, but then suddenly T is no longer true. So now if I run the same code, I get a very different value because T is now false and is no longer true. And it doesn't even give you a warning. T is a big vector with all kinds of numbers. It doesn't even look like true or false. R will not give you a warning. It will just treat T as false. This cannot happen with the letters true, so you cannot, for example, overwrite true. R will give an error. You can't do that. This is very risky. So for example, if you have code where you use T and F, and you know that you shouldn't overwrite T and F, but you might run someone else's code that did do that and you don't even know it, and then suddenly your code doesn't work anymore. This once cost me a full day of debugging something because a colleague of mine sent me code that did exactly that. And ever since, I always recommend people, okay, it's not going to save you that much time to not write out those 3 extra letters from true, for example. But it will save you a lot of time if you are going to encounter this problem and you don't know what's happening. So always write out true and false and never use T and F. Tip number 4 is something a bit more general in R, and that is, in general, you want to avoid using for loops as much as you can. And this might be something that's a bit weird for people that go into R from other programming languages, where usually the for loop is the first thing you go to solve your problem. In R, the for loop doesn't work very well. And that is because R is not a compiled language, it's an interpreted language, which means that it doesn't have a program that does something 100 times. For example, if I write for something 100 times, and then I do something inside it, R will open that program and close the program 100 times. It doesn't know it's going to do that 100 times. And that costs a lot of time to open and close a program. So for example, if I say in the for loop sum something, it will go open up the sum program and close the sum program every time it encounters it, rather than knowing that it will have to do that 100 times. So for example, here I make 2 vectors. And they're very big. So 1e8 stands for 10 to the power of 8. So these are a lot of numbers, and now I want to add them. One way that we can do this, and which is a bit like how we do it in C++, is to make a new vector and then run a for loop that adds every element of it. And as you see, this took some time. It's not super long, of course. This is still something that R can do, but it took some time. Another thing we can do in R is we can actually use vectorized statements. So here I add the vector x to the vector y. This is much, much faster. And that is because here the plus program is called only once, but with vectors input, where here the plus program is called 10 to the power of 8 times, and that takes much longer. So to compare this, we can run this micro benchmark, and this will take some time because it will run all these codes 5 times in this case. And now it's done, and we can see that the for loop actually took much, much longer than the vectorized statement. Now here, this for loop we could still do. You get the problem even more if you do for loops, nested in for loops, nested in for loops. Usually there is a better way to do this stuff in R. If you use vectorized statements or if you're really smart about the way that you do things. Now, if you really need to use for loops in R and they are really long, you could actually do that, but then I recommend that you look at the RCPP package so that you can use C++ code directly in R. C++ is much harder to use than R, and you can actually make like entire programs out of it, but you can also use a little bit of C++ just for the one for loop that you have that you need to make faster. And this is something, for example, that I do in the psychometrics package, where most of the package is in R, but all the numerical optimization is happening in C++, which is just much faster. Tip number 5 is that whenever you make functions or R code or anything that you use, especially if you're developing methods and you want other people to use those methods, write your code in R packages. R packages are very easy to make, and they're just a structure of folders that you can use to put your R codes in and to document your R codes. They also allow you to check the R code for any mistakes and make sure that it's well documented. It's very easy to use, and it's very easy to share R packages. You can upload them to crun, or you can just put them on GitHub and people can install them directly from GitHub. And it will make sure that you can share your code much more easily, and that also the code is documented and much easier to use. Now, making an R package is not as hard as many people think. It is very easy to do, or at least to get started. In RStudio, for example, you can just go to new project, new directory, R package, just say some name. For your R package, say create project. And then it will do the first steps for you. It will create the folder structure you need. It will create some example R code that you can use as well. The description file that will tell you what the name is and description of the package. Namespace that you can use to say which functions you make available to the users. And this will already work. There's a build tab. You can install the package. And then you can see here that we can use the package like that. And we can even request the help page, which already works as well. Another very useful thing in RStudio, if you have DevTools installed, DEVTOOLS, you can press Command-Shift-L or Control-Shift-L to load all the packages, functions in your package, including hidden ones. And then I can also use hello. Very useful for programming and testing out new functions as well. Now, an R package also does not have to be big. Here's an example of an R package that I wrote, which is called parsim. And it only really has one function in there called parsim. And the code is not that long for this. It's not like thousands of lines of code. It's a file with 151 lines. And it was just a very useful function, so I made it available in an R package, and it's on crun. It's just to show that you don't have to make like a super big package. But of course, if you want to, you can make a big package. So this is the psychometrics package here. And this package actually has a ton of R script in there, a ton of different functions that you use. And it also has a ton of C++ code in there. The sky is really the limit how much you want to put in an R package. Okay, and then for the last tip, and it's something that I use almost every day, especially when I'm programming R package, I use it all the time. It's the best function that exists in R, and that is the function browser. BROWSER, open bracket, closing bracket. Learn this function, get to know this function, love this function. It's amazing what you can do with it. So what can you do with browser? The thing that browser does is the moment you run it, you get into a browser. And then I can look and I can just type R code and see what's available in my environment. And I can press capital Q to quit it. Now that's not spectacular. What's nice is that you can call this anywhere. For example, here I make two vectors. I create my silly for loop that I used earlier, but we actually won't want to use, of course. And now R stopped running the moment it encountered browser, and it allowed me to look inside the for loop. So now I can see what is I. I is 1. What is X, index I? That is this number. I can press C, then it will continue until the next time browser is called, which in this case is when I is 2. And I can see what happens to X, and X is this number now. And that allows me to really look inside a for loop. It also can be used inside, for example, a function. So here I define a function. It's an empty function. I only have arguments. I call it, and now I can also go back here. Now I am inside the function. So now I can actually call arg1, arg2, arguments that I defined here, and I can program here in R as if I were inside the function, which is just extremely useful. If you're making a new function, you might want to know what's happening somewhere in that function. You can use browser in a small function like I did here, but of course you can also use browser in much larger functions and in R packages. So it's extremely useful if you are debugging R packages. For example, here I simulate some data under a factor model, a confirmatory factor analysis model. If you know psychometrics, then that will ring a bell to you. Otherwise, it doesn't really matter. And I wrote this R package that can handle this type of data called psychometrics. And this R package can be used to do, for example, factor analysis. I can press Command-Shift-L because I have the project open. I load all the functions. Then I can run the factor analysis here, and I get some values here. You get some errors, but you can ignore those. You get some values here, and these values, they are obtained from a numerical optimization algorithm. A numerical optimization algorithm uses starting values to find the optimal final values. And this might give some problems, so I might want to debug here. So how do I do that? Go to File, Open. I can look for the file that I need to use, that is this file here in this very long list of functions. I get this function here, which is a function that's used inside another function, in psychometrics somewhere. So it's like very, very deep nested. And then I can look at this function. Okay, so somewhere here I define the starting values. So let's see what happens here. I type browser, save the file, Command-Shift-L to load all the functions again. Now, if I run this command here, it will actually stop running at this point. It will even switch to the correct script and it will tell me I am here. Now I can look inside this function. So now I can see, okay, what is lambda start here? That's the starting values. And I can see how I defined them. So here I have some other starting values, for example, this is 1 in this case. And I can look at all these objects that I use here and see what is exactly happening here, and also make changes and see how that will impact the results. Another thing I can use browser for is to debug, for example, Shiny applications. So here I have the R code of a very big Shiny application that we made, and it's a very big code here. And for example, here in the server we use a function called plotter_radial that is defined in the global.r file, which is again a very big file. It has all kinds of things in there, including the definition of this function. And I might want to see how this works. So I could say, okay, so something is happening here. So here I want to see what does this function do. So browser, Shift Command S to save. And now I can run the application. And there we are. Now the application is running. I go to whatever tab is necessary here. Say, okay, create plot. And I know this is the part where this function is called. Now what's happening here? Well, you see here in Shiny, nothing is happening. But in R, if we go to the console, I have again a browser window. And this will actually give me all the objects that I have here. I can just look exactly what is happening now in this function. What does this data that I use look like? What are the arguments here? Anything is defined here. There's a function here. I can look at it, I can use it. I am just here in this function that is called from within the Shiny application. Extremely useful way to debug and see what's happening. Very easy to use. And yeah, I use it almost every day if I'm programming in R. And that's it for these 6 tips that I thought would be very useful for anyone that is using R. Thank you for watching this video. I am going to upload more videos about R programming, about mathematics, and about how to use my software packages like psychometrics in the future. So keep an eye out for that if you're interested in that.